Okay, so let's start with the next questions. That is question number 14. Chapter is Alcohol, Phenols and Ethers. Class is 12th. NCERT back exercise chemistry we are solving. And if you need the solutions to the previous questions, that is questions before 14th question, I have given the link to that video in the description of this video. Okay, you can just go there and get the solutions to that. All right, let's now see what is the statement for question number 14th. 11.14 question. Give two reasons that show the acidic nature of phenol. Okay, give two, not reasons, it is the two reactions that show the acidic nature of phenol. Compare acidity of phenol with that of ethanol. Okay, let's take the first part first. We need to give two reactions which show the acidic nature of phenol. Okay, you just can take phenol and react it with, you can take NaOH, that is the base. So it will lead to the formation of sodium phenoxide plus water. So this is one reaction which is showing the acidic behavior of phenol. Then the second reaction can be reaction of phenol with sodium metal. So it will lead to the formation of again sodium phenoxide, and hydrogen gas will be liberated. Okay, so we need two of this will be found, two here. Oh, right. Okay, so these are the two reactions which are showing the acidic nature of phenol. Let's now move on into the second part of the question. Compare acidity of phenol with that of ethanol. Okay, phenol and ethanol, we need to compare the acidity of both. Phenol is there, ethanol is there. Okay, now what is the acidity? Acidity is the tendency of a molecule to release proton. Okay, both of these, they release proton. One is a strong acid and other is a weak acid. Phenol is stronger than ethanol. We need to explain why phenol is a stronger acid than ethanol. Now for this, what we will do is, we will be taking up two conditions. One is before the release of proton, the other one is after the release of proton. So one is before the release of proton. So there are always two explanations to these kind of questions. Before the release of proton first. Now when proton has not been released, what is the structure of phenol? The lone pair of electrons on oxygen, they are in conjugation with the pi electrons of benzene ring. Because of which what happens is, there will be a double bond between oxygen and hydrogen, and oxygen will get a positive charge. Now this positive charge on oxygen is unstable. What it will try to do, it will try to attract the shared pair of electrons between it and hydrogen towards itself. To stabilize itself, it will attract this shared pair of electron with it towards itself. This means by doing so, the polarity of the OH bond, it will increase. Any factor that will lead to the increase in polarity of this OH bond will lead to increase in the acidic character. Now, because oxygen can attract this shared pair of electrons towards itself with more strength because of the positive charge, this will be released very easily. So this is increasing the acidic strength of phenol. Now let's move into C2H5OH or CH3CH2OH, that is ethanol. Now what is the scene here? In this case, the lone pair of electron on oxygen, it is not in conjugation with anything because there is nothing to conjugate with it. Okay, but at the same time, this alkyl group, that is the ethyl group, it is having plus I effect. Because of the plus I effect of the ethyl group, what will happen? The electron density on oxygen will increase. Electron density on oxygen will increase. Now, though oxygen is highly electronegative, it is very highly electronegative as compared to hydrogen, still its tendency to attract the shared pair of electron towards itself, it will decrease. Its tendency to attract the shared pair of electrons towards itself, it will decrease because of the plus I effect of the ethyl group. This means the release of proton, it will become difficult because ethyl group is releasing its electrons towards oxygen, leading to lesser polarity of this OH bond. Due to decrease in the polarity of the OH bond, the acidic character is lesser. Hope this is clear to you. The next is the second explanation. Second explanation is after the release of proton. After the release of proton. Now, when we are talking about after the release of proton, we need to see the stability of the ion which is formed after the release of proton. Okay. Now, in case of phenol, phenoxide ion will be formed when proton will be released. So this is phenoxide ion. Okay. In case of alcohol, that is ethyl alcohol or ethanol, ethoxide ion will be formed after the release of proton. Now, out of these two, whichever will be more stable, it will be formed more easily. Phenoxide ion is more stable because of the resonance. So I will draw one resonating structure here for you. You can draw all the resonating structures. You need to draw all the resonating structures. Okay. So what will happen? The negative charge which appeared on this oxygen atom after the loss of proton, it is now delocalized on benzene ring. So there is delocalization of negative charge. Now, whenever there will be delocalization of any charge, it will lead to stability. This means phenoxide ion is stable. If phenoxide ion is stable, this means phenol can very easily release its proton, because even after the release of the proton, the resultant ion formed is still stable. Okay, then come to this ion, that is the ethoxide ion. What will happen in this case? Oxygen is already carrying a negative charge. There is nothing which can share its negative charge or which can delocalize its negative charge. So no delocalization is there. No delocalization. Number one, there is no delocalization. At the same time, what is happening? There is plus I effect of the ethyl group. Due to the plus I effect of ethyl group, the negative charge on oxygen is getting intensified. It actually needed to stabilize the negative charge by delocalization, but instead of stabilizing it by delocalization, it is actually intensifying the negative charge. Just giving you an example, suppose you are carrying a burden, okay, and just like in case of phenoxide ion, one of your friends, he is coming to you and telling you that, okay, I can share this burden with you. What will you feel? You will feel stable. And there is somebody else who is coming to you and putting more burden on you. What will happen? You will become unstable. So you will try to not have any kind of burden, because you know people will come and put more burden on you. All right. So just like that, so ethanol, it will try to remain ethanol. It will not try to go into it will not try to form the ethoxide ion, because it is unstable because of intensification of the negative charge. Okay, so these are the two explanations, and depending upon the marks of the question, you need to sometimes you need to take both the explanations in the exam. Okay. All right. So hope this is clear to you. Still you have any kind of problem, I'm here to help you out. Comment section is there below the video. Put the comment and write your query there. Okay. Next is question number, I think we need to do the 15th question now. Okay. 11.15. Question number 11.15. Explain why is orthonitrophenol more acidic than orthomethoxyphenol. Orthonitrophenol. Okay. At the ortho position, there is nitro group. And then there is orthomethoxyphenol. Now we need to explain why orthonitrophenol is more acidic than orthomethoxyphenol. Again, similar example, we will be having the similar explanation. One is before the release of proton, other is after the release of proton. Okay, now we have already discussed that any group that will increase the polarity of the OH group, it will increase the acidic nature. All right, now in this case, in case of orthonitrophenol, what's happening here is the nitrophenol, nitro group, it is having minus I effect and minus R effect also. That is, it takes away the electrons. So these are the electrons on oxygen atom. They are in conjugation with the pi electrons of benzene ring. Now what will happen? This will move here. I'm showing it in this single structure, okay? You can draw all the resonating structures. What will happen then? It will go here and here. I'm finishing it off in the single structure. Hope you know how to draw the resonating structures. So what will happen? It is leading to the appearance of positive charge on the oxygen atom of OH group. Like this. Now it is increasing the polarity of OH group because oxygen is carrying a positive charge. So its tendency to attract this shared pair of electrons towards itself, it will increase and it will easily release the proton. Okay. On the other hand, when we are talking about orthomethoxyphenol, what will happen? In case of orthomethoxyphenol, there is a lone pair of electrons on the methoxy group. It will release its electrons. It is having plus R effect. Due to the plus R effect, it will release its electrons towards the benzene ring. When it will release the electrons towards the benzene ring, what will happen then? Here, it will move here, this will move here, and this will move here. Now, like this. This negative and the lone pairs, they are very close to each other. This is leading to destabilization. This will lead to destabilization. And what will happen? The polarity of this OH bond, it will decrease because there is already a negative charge near to oxygen atom. So the release of proton, it will become difficult. This is the first explanation before the release of proton. Now let's move into the second explanation, that is when the proton has already been released, then what will happen? Okay, so when the proton is already released, we have phenoxide ion. Oxygen is carrying a negative charge. There is NO2 group. Okay, now what will happen? This negative charge is in conjugation with this double bond. The negative charge will appear here. Okay. Now this negative charge, which is on carbon, it is in conjugation with the double bond of this oxygen. So I'm drawing only these many resonating structures. Now what is exactly happening? The negative charge, it is getting delocalized over the nitro group. This means it is helping to hold this burden of negative charge. So it will stabilize this phenoxide ion. Now, because it is stabilizing the phenoxide ion, this means it will help it to release the proton, because even if the proton is released, it is there to stabilize the phenoxide ion. But in the other case, when methoxy group is there at the ortho position, then what will happen? Now, this will go here. Okay, this is in conjugation with the pi electrons of benzene ring, but at the same time, these electrons on this oxygen atom, they are also in conjugation with the pi electrons of benzene ring, and these electrons will be released towards the benzene ring. So what will happen now? Okay, we can just do not use this structure. I'm drawing another structure so that you can understand it better. So this is the conjugation with the methoxy group. Now what is happening here? Already this oxygen is carrying a negative charge. On the other hand, what's happening is oxygen of methoxy group, it is releasing its electrons towards the carbon to which the negative oxygen is attached directly. Two negative charges are appearing on the adjacent atoms. So there will be huge repulsive forces. Due to those huge repulsive forces, there is destabilization. So whenever there is repulsive force, it leads to destabilization. Whenever there is an attractive force, it leads to stabilization. Now, because these similar charges are present on the two adjacent atoms, that is one on oxygen atom and other on the carbon atom, it will lead to destabilization of the phenoxide ion formed in case of ortho-methoxyphenol. Okay, so instead of delocalizing, it is intensifying the negative charge. It is bringing the negative charge near to the already present negative charge. Hope this is clear to you. So this is the explanation for this. And let's now move into the next question. Hope I have completed this question. Is there any other part or something? No, there's no other part. We can move to the next question. Question number 11.16. Explain how does the OH group attached to a carbon of benzene ring activate it towards electrophilic substitution. Explain how does the OH group attached to a carbon of benzene ring activate it towards electrophilic substitution. Okay, we have benzene ring and we have OH group attached to it. That is, we have phenol. We need to explain how it will activate the benzene ring towards the further electrophilic substitution reactions. Benzene, it undergoes electrophilic substitution reactions. That is, electrophile has to attack. Electrophile is a species which is electron loving. Electrophile means electron loving. Okay, so wherever it will find more electron density, it will attack there on the benzene ring. Now we are saying that OH group, it activates the benzene ring towards the further attack of the electrophile, that is towards electrophilic substitution reaction. Why so? Because of its plus R effect. The lone pair of electrons on oxygen, they are in conjugation with the pi electrons of benzene ring. So resonance will occur. So this will get a positive charge and there will be a negative charge on the benzene ring. So we can just draw all the resonating structures which are involved here. Try to draw them yourself and then you can check it whether you are drawing it right or not. Okay. So these are the resonating structures. Now, if you observe these resonating structures, you will be able to see that there is increase in electron density on the benzene ring. Negative charge is appearing on the benzene ring because the lone pair of electrons on oxygen atom of OH group, they are in conjugation with the pi electrons of benzene ring. Because of that conjugation, what is happening? The electron density on the benzene ring, it is increasing. Now, when this electron density is increasing on the benzene ring, it will make it easier for the electrophile to attack on the benzene ring. That is, it will facilitate the attack of electrophile on benzene ring. So that is why the OH group, it increases the reactivity of benzene ring towards further electrophilic substitution reactions. Now, where will the electrophile attack? It will either attack on the ortho position or it will attack on the para position. Either on the ortho position or on the para position, because the negative electron density, it is increasing at these two positions. There is no impact on the meta position. So the incoming electrophile, it will not attack on the meta position, but it will preferably attack on the ortho and para position. Hope this is clear to you. So I think this is enough for this video. I do not want to overburden you. Just absorb these concepts first. Do them again. Just watch this video again if you need. If you have taken all the notes, just go to your notes and revise them. Okay, revise your notes, and definitely you will get a lot of clarity. And still, if you are facing any kind of problem, you can just write to me in the comment section below. And if you just need to learn from me in my live online classes, go to the description of this video and you can reach out to me. From there, I have given how you can reach out to me. Okay, so I will see you in the next video. All the best. God bless.